Why do I prepare solutions? To use them, they're right. And we use them where? In solution stoichiometry. How many grams of NaOH are needed to neutralize 20 milli 0.15 molar H2SO4? A neutralization reaction, it's an acid-base reaction. Base, acid, base, acid, give me salt and water. Give me what? Salt and water. The same thing. Moles, moles, masses. But how much? Here's the moles is from solution. It's not mass over molar mass. It is what? Volume multiplied by molarity. What do I have? I have the molarity of H2SO4 and the volume of H2SO4. Remember, if you calculate moles, you need to have the volume in liter. If you calculate millimoles, you need to take the volume in millis. Okay? Here, moles H2SO4, 20 milli, it's 0.02 liter. It's 0.02 liter multiplied by what? The molarity, mole per liter. Moles H2SO4. Balanced chemical equation, 2 NaOH over 1. 2 over 1. Okay. I have moles NaOH. If it's solid material, I multiply by what? By molar mass. So the mass of NaOH to neutralize this reaction is 0.24 grams. Is what? Is 0.24 grams. Okay? It means that NaOH react with H2SO4 in solution. So the moles of H2SO4, volume in liter, multiplied by mole, multiplied by molar. Okay? Millis HCl required to react with 1 gram calcium carbonate. Calcium carbonate solid, the moles mass over molar mass. Go to moles of HCl from the balanced equation, 2 over 1. HCl now is a solution. I have its moles. If I need volume, I multiply by molarity. But the volume calculated will be in liters, okay? Okay? If I need molarity, I divide by the volume in liter. Here's what he needs. He needs the volume of HCl. I calculated in liter, okay? When I divide by the molarity, then to give it in milli, I multiplied by 1000, which 10 to power 3. It means what? It means if you have solution, okay, you can go from moles either to molarity or to volume. Remember, the volume in calculation comes from what? From volume in liter. How many grams of AgCl will be produced from the reaction of 50 milli AgNO3 and 60 milli NaCl? I need to calculate the product with what? 2 reactants. So here I go to the what? I go to the limiting reactant. I have to go to check with one is the limiting reactant. Moles AgNO3, 0.005. Moles NaCl, 0.006. Is that right? Okay. Because moles here simple. Volume multiplied by molarity. Okay. And I want to check for NaCl. Required how much? AgNO3 1 over 1. What I have? 0.006. Okay. NaCl is the excess reactant. Okay. Ag is the limiting. Moles AgNO3. Moles AgCl multiplied 1 over 1. Mass multiplied by what? 143.5. It is 0.718 grams. 0.718 grams. Okay. In solution stoichiometry, I still have the limiting reactant. What's new in solution stoichiometry? That reactions are between solutions. It means that the reactants have to go to ions. Okay. AgNO3, it will go to Ag plus NO3 minus. NaCl, Na plus, Cl minus. Then Ag plus react with Cl minus to form solid AgCl. Okay, so calculations are in what? In solutions. What's new in this problem? We have the limiting reactant. Limiting reactant is following you, okay? Be careful. The reaction between solutions, we name it titration. We name it what? We name it titration. What's titration? Titration, it means a chemical reaction. One down and one upper. One here in the flask, in the Erlenmeyer, we take fixed volume and we add indicator and we start adding the other reactant gradually. When the reaction is finished, when the color of indicator changes. When what? When the color of what? When the color it changes. What does that mean? It told me that the reaction is finished. What does that mean? You can make stoichiometric calculations. Moles of reactant A, which is the volume which you put, multiplied by its molarity. Here, the moles of added, which is the volume required to change the indicator, multiplied by the molarity. You multiply by the stoichiometric ratio from what? From the balanced chemical equation. From what? From the balanced chemical equation. Okay? Here. So, the equation, it has one theoretical, we name it equivalence. We name it what? Equivalence. The one experimental, we name it end. We have equivalent point, and we detect the equivalent point with an indicator, and the one we get from the indicator, we name it what? End point. Our work is correct if the equivalent point and end point are the same. Okay. You see here what? I am doing the titration between H2SO4, sorry, and what? And NaO and NaOH. It's an acid-base reaction. The equation H2SO4 زائد 2NaOH بيعطيني Na2SO4 زائد 2H2O. How much? I put indicator. Phenolphthalein. In acidic, it's colorless. So I add the base. When the reaction is finished, the first at end point, the first excess NaOH point, it changed the color from what? From colorless to pink. From what? From colorless to pink, which I name it the end point. So we name the reaction is what? Is titration. Okay. Question, what is the molarity of NaOH if 48 milli neutralize 35 milli of 0.144 molar H2SO4? So it is a titration reaction, neutralization reaction between what? H2SO4 and NaOH. What I was given, volume H2SO4 and its molarity. So I have millimoles. If I work in volumes, I use millimoles. Okay, if this is solution and this is solution, it's better to use volumes. Okay, millimoles H2SO4, volume in milli multiplied by molarity. Millimoles NaOH multiplied by 2/1. I have millimoles NaOH. If I divide by the volume in millis, I get the molarity. If I divide by the molarity, I get the volume in milli. But here what I need? I need the molarity. So I divide by what? By the volume of NaOH. And this solution is how much? It's 0.21 mole per liter. Another example. This reaction is what? It's oxidation reduction reaction. Oxidation reduction reaction. It will mean what? Between iodide and KMnO4, which is potassium permanganate. Potassium permanganate. H2SO4 here, it's an acidic medium. It has nothing to do with calculations. It's acidic medium. Okay? So the reaction is between HI and KMnO4. The product is iodine. Okay? He's asking me about what? About HI. What's he's giving me? He is giving me volume of KMnO4 and molarity of KMnO4. So I calculate the millimoles of KMnO4. I need the millimoles HI. I go to what? I go to the balanced chemical equation. I go to what? To the balanced chemical equation, which is 10 over 2. 10 over 2. So now I have millimoles HI. I need the volume. I divide by the molarity. I need the molarity. I divide by the volume. He is asking me here by what? By the volume. So I divide by the molarity of 0.206. It's 20.4 milli. He asked me, what's the indicator here? There is no indicator here because KMnO4, it's pink. It's what? It's pink. Since it's reacted, KMnO4 goes to Mn, colorless. 1 point excess KMnO4, the solution will become pink. From where? From KMnO4. So KMnO4 is called self-indicator. Okay. And that's it for solution stoichiometry. Okay, just look for the number of moles, mass over molar mass, or volume multiplied by molarity. What's given and what's asked. Read the question carefully. Thank you.